In this video, I'm going to be explaining how to find derivatives using a table of values. So let's do a first example here. Given some random function called h, the value of that function h is the sum of the functions f and g. And I want to be able to evaluate the derivative of the function h at 1, or an x value of 1. Well, the derivative of this function is going to be using the sum and difference rule, which says that I could take the derivative of one function plus the derivative of another function. So let's just rewrite it in function notation first. So if I want to evaluate the derivative of the function h at 1, that would be evaluating the function, the derivative of f at 1 plus the derivative of g at 1. And we can use our table to get the values we need and just substitute. So we're looking under the derivative column. Here is a bunch of columns. We got the function f, the derivative of the function f, the function g, and the derivative of the function g. And then we're given all of the values when we evaluate these x values. So I'm looking under the derivative of f column evaluated at 1. So if I'm plugging x equals 1 in to my derivative of f column, I get negative 2. Do the same thing but with our g. The derivative of g evaluated at 1 is 1. So negative 2 plus 1 is negative 1. Let's do another one. This time I have a function h, and its value is given by the difference of the function f and the function g. And I want to be able to find or evaluate the derivative of the h function at 4. Well, first let's figure out how to find the derivative of h. This is just a difference equation, so I can find the derivative of each function individually and subtract them. So the derivative of h is the derivative of f minus the derivative of g. And we're going to evaluate that at 4. So I want to find my derivative column evaluated at 4 for the f function. Here's our derivative of f evaluated at 4. Well, it's 1. So I substitute 1 for that spot. Then look under the derivative column for g evaluated at 4. I'm told that it's negative 2. So I'm doing 1 minus negative 2, which turns into 1 plus 2, which is 3. So we're using our sum and difference rule and substituting using the values in the table. Let's do some more examples. This time I'm told that the h function is the product of the functions f and g. So the derivative of h must be the derivative of f and the derivative of g using our product rule, and then we're going to evaluate it at 4. So first let's figure out what our product rule would be for these functions in function notation. So the derivative of h evaluated at 4 would be our product rule, which says it's the derivative of f times g plus f times the derivative of g. And then we can look in our table and substitute those values. So the derivative of f evaluated at 4 is negative 2. The function g evaluated at 4 is using this column, and we're told that that value is 4. So we have negative 2 times 4 first. Then over here to substitute, we're looking in our f function column and evaluating it at 4. So here's the function f evaluated at 4, we're told is 2. And then the derivative of g column evaluated at 4 is 1. So we got 2 times 1 over here on this side. So negative 2 times 4 is negative 8. 2 times 1 is 2. And negative 8 plus 2 is negative 6. So we just used our product rule and then substituted values from the table. Let's do another one. This time we're told that a function h is the quotient of the functions f and g. So let's find the derivative of h evaluated at 2. Well, if I want to find the derivative of a quotient, I have to use my quotient rule, which says that it's the derivative of f times g minus f times the derivative of g all over the function g squared. Now we want to evaluate that at 2. So I'm going to look for the derivative of f column evaluated at 2, that's 1. And then I want to evaluate my g function at 2, and that's 2. Then I want to evaluate the function f at 2, so that's 3. And then I want to evaluate the derivative of g at 2, which is 1. Then on the bottom, I want to evaluate the g function at 2, and I want to square that, so 2 squared on the bottom. So then simplify. 1 times 2 is 2, 3 times 1 is 3, and 2 squared on the bottom is 4. Keep simplifying. 2 minus 3 divided by 4 is negative 1/4. So that time we used our quotient rule and then substituted values from the table. One more pair of examples here. This time we're going to be using the chain rule. So we're told that the function h is the function f squared. So what is the derivative of that evaluated at 3? Well, if I want to find the derivative of a function squared, I have two levels here. I have something squared and then the function f. That would be two levels of my chain rule. So I'm going to find the derivative of something squared. I'm going to put the exponent in front and subtract 1 from the exponent, and then keep the inside the same. And then I'm going to multiply by the derivative of that inside function. So we're evaluating this all at 3. First, I want to evaluate inside and work outside when I use nested functions. So evaluating f of 3, the function f at 3 is 4. I'm going to multiply 2 times 4 there. And then I'm going to substitute my value for the derivative of f evaluated at 3, which is 0. 2 times 4 is 8, but anything times 0 is going to give me 0. One more time, let's do a nested function here. That's the function h, is if I plug the function g into f. So if I want to find that derivative, I got to use the chain rule again, and then we're going to evaluate it at 4. So the chain rule says that I take the derivative of the outside function and keep the inside function the same, and then multiply by the derivative of the inside function. So again, we're going to work inside out. I want to evaluate g of 4 first. So the function g evaluated at 4 is 3. And then that's going to get plugged into the derivative of f. So the derivative of f evaluated at 3 is 0. Then let's figure out what the derivative of g evaluated at 4 is. It's 2. So I have 0 times 2, which is 0. So there's some examples using the chain rule.